All right. So anyway, so homework number one, number 4. Okay. So what's number 4? The question for number 4 is, let me write down the problem. It's very quick. It says that, okay, so assume I have UTT minus the Laplacian U plus D is a constant, U sub T equal to 0 in Rn class 0 infinity, okay? And then infinity. And then where D is positive, okay? This kind of equation is called damping. Damped. This is the first two terms wave equation, but with this term they call it damped because this U sub T is like velocity. Du sub T is like if you're say running, right? So think about you're running and something coming up to you that push you, so something like that. So this term is called damping term. So damping is one derivative in T, one derivative in T, one derivative in T. Okay. Yes. Okay. Okay. So he says, suppose I have this function. Then the idea is to find. So what he says, find a simple exponential term. Exponential. So find a function f such that a simple. And he said that he mentioned that this could, I mean, this should be an exponential. Okay. But anyway, the idea is to find f such that if I multiply f by u, so if I such that if we let v to be f times u, then v satisfies vtt minus the Laplacian v plus c v equal to 0. But then the point right now is c now is negative. C now is from d going now c is negative. That's the point. From positive here, d, and now c is negative. Okay. So the important thing about this is that this equation provides this equation is easier to solve than this one because this has a derivative and this doesn't have a derivative. Of course, the sign changes, but the nature is that this one is easier to solve. Okay, so the hint I gave you is, I didn't really give you any hint. I just say that we should really satisfy that. Okay, so no problem. We'll just do it. Okay, so I really not giving you any hint. Okay, so I'm not going to let f to be a function of t at all. Okay, just t. So if this has to satisfy this, right? So I just substitute this. I mean, substitute into this one. Okay, so actually the first two terms. So v sub t, all right. So it's f u t, right? So it's f sub t, so with prime, right? U plus f u t, right? And then v t t, one more. So f t t, u plus 2 f t u t, right? Plus f u t t. Okay, and then the Laplacian v, well, the Laplacian, because the Laplacian is only on x, not on f. So I mean not on t, so I can bring the f out. So I have this one. Okay, so I have this and this one. So now I'm going to, so vtt minus the Laplacian v, right? Subtract, because I want this to be this one, and from here to here. So okay, so let's just check. Okay, so go ahead. So vtt minus this is equal to, okay, so this minus this. So just write this slowly. fttu plus 2ftut plus futt minus f Laplacian u. Okay, all right. But I know that I'm going to factor f out from here. So this utt minus the Laplacian u. So f I'm factoring f out, so I have utt minus Laplace and u. And I know what this is, what this should be, because from the original equation, right, this guy is utt minus Laplace and u should be minus du sub t. This is from the original equation. Original equation that this plus this equal to 0, so this equal to negative of this. Okay, and then I want this to be equal to c we want. Let me first simplify this. So I have fttu plus 2ft. Right? I'm just combining the like terms minus df and then u sub t. Okay? So combine these two terms. And then this we want, right? We want this to be equal to minus cv, right? So which is minus cfu. We want these two to be the same. So what condition can this be the same? We want this. So therefore, if I compare, right? If I compare these two conditions, if I compare these two, therefore, okay, I have FTT, I mean two derivatives, must be minus CF. Right? This guy must be equal to this guy. I mean, this guy must be equal to this guy. And this guy must be 0. 2FT minus DF must be 0. I must have these two. Because this is the coefficient of U sub T. And this is the coefficient of U. In order for them to be to balance, this must be with this. This must be 0. So this is how I'm going to solve for f. So 2ft, so actually I can solve from here. 2ft is equal to df, right? So solve this. So what? So f sub t is d over 2f. So what's the solution f? F of t is a constant, right? So I already have this. Let me put c sub 1, e to the d over the 2t. This is the solution for this guy. Okay? Then, but I need to decide what c sub 1 is. I'm going to plug this into this equation. So f sub t is c1 d of 2, right? D over 2, e to the d over 2t. ftt c1 d over 2 square, e d over 2t. So, and this one we want this to be cf. But what is f? I already know what f is. F is minus c1, right? E d over 2t. So if I compare this, compare this with this one, so I get well, c1 cancel, right? So let me do it sorry. D squared over 4, and this also cancel. So d squared over 4 is equal to minus c. So c is, I have d. Yeah, c is minus d squared over 4. Okay, so finally, so what is the answer? Oh, I did too much. F of t is C1 is cancelled. C1 can be anything. Oh, okay. Well, so looks like C1 can be anything because I cancel the C1. So F of t. So one example of Ft would be e to the d over 2t. But then the C, so our equation Vtt minus the Laplacian V plus Cv equal to 0. This C must be minus d squared over 4. Right, so this equation for the newer one, this C must be this one. So that's why he said that the original D is positive. I mean, actually, no matter whether D is positive or negative, C must be a negative number. All right, so that's the next problem is leave a tree here. The next one. So this is 1, 2. Because next one is a lot of computation. This is probably not. So okay, let's look at number 6. Number 6 is that I have this UTT minus the constant U equal to 0, U equal to G, U equal to H, U sub T equal to H as the initial condition in R3, 0 infinity, R3, T equal to 0. So they want us to show G and H have compact support. So that means, so in other words, so there exists, there's a say, I have R here. So I don't want to confuse with this R. So probably assume M by positive such that G of X will be 0 for X bigger than M, and the H of X will be 0 for X greater than M. So compact support means outside the compact set, or outside the ball is all 0. So that's really what this means. And then what they want us to show, this is what they want to show, that the solution UXT is less or equal to C over T. Yeah, it's a recording. Well, for all X belongs to R3 and T greater than 0. So I want to show this one. So of course, we have to, the hint, use the representation formula for the solution in 2.4.1, right? I actually did not do any kind of really, my hint is really not really hint. But anyway, let's look at formula 2.4.1. What's that? So the formula 2.4.1, it is this formula. Okay, one moment is here. What do I mean here? So for formula 22 on page 72. Here, this one. So the formula, okay, so from page 72, formula 22, U of xt is equal to, now this is bar here, this means average, this means boundary, that's xt, t, h of y, to that point y, plus g of y, plus d gy dot y minus x, and then this is the function you are going to integrate, but you are integrate on the boundary of this ball. So it's the surface integral s y. Okay. So this is y. This is from 22. Okay. So let us understand what this means. So if I look at, the formula for that is in appendix. So if I look at appendix, I give you page number is it is A3, page 700. So I have actually 702. It's this formula. So it's formula, page 702. Yeah. So it's equal to 1 over n is 3.